who is Alessandro Vinciarelli, originally from Italy, but now of the University of Glasgow and the EDIAP Research Institute. What EDIAP means, I never remember, but I'm sure that Alessandro, in some sense, maybe you are the originator of SSP. You
yes,
are.
Yes, one of.
If you want to be modest, you can.
Yeah.
You can not. So, if you want to have a Mr. Social Signal Processing, this is the man. And so now he will tell you about social signal processing, and I suspect not the whole thing, but concentrating on personality.
Yes.
And he has been here before, and I'm very much looking forward to this. So, Alessandro, come here.
Okay, thank you. Thank you very much. Thank you very much for the school for inviting me. It's always a great pleasure to be here. So actually the talk is going to be mainly about personality, but I think it was nice as well at the beginning of the school, and I heard Jens is going to present something about social signal processing. I'm sure Mark maybe will do as well. I think it was interesting to start to see how something like social signal processing can come in the mind of a computer science person, because in the end that's what I am. I'm a technology guy. I think it's fun to see, especially for those who maybe belong to different fields, to see how a computer scientist can come to this type of topics that is not really, let's say, peculiar or specific of computing science. So first of all, I'm going to show that this is part of something bigger that I call the rise of socialism in computing science. We will see what it is. Then I'm going to show in particular what SSP is. And then for school program, don't forget about it, but because it comes from an old school I organized, and then some very quick words of conclusion. So first of all, what do we mean by the rise of socialism? And I think here is a funny picture, because what I did, it was very simple. I took a mailing list, which is called behavioural. It is a technological mailing list. It's a type of place where people advertise information about summer schools, conferences, workshops, and so on. And so it's a kind of thermometer of what are the important topics in a given community. In this case, it's the multimedia community. And what I did, it was simply to count the number of events with the word social in their title, whatever that means, all over the years. And it is not accumulative, it is year by year. So you see, in 2004, it was basically something absent. Until 2007, it's kind of marginal. Then something happens, and you see that it starts growing. Can anybody guess what actually happened roughly this time that has triggered a bit of interest?
Facebook.
Exactly. These are the birth dates of the most important social media, and I think that has really been the type of event that has triggered very much interest for any type of social aspect of computing. And it has also shaped a bit the community, because when you say social in the title, it can mean a large number of different things. But when you go to see, you see that the biggest communities are mainly social network analysis, and everything has to do with social media. But then there are also a nice number of other communities, like very old social technical systems community. So people who study how technology changes communities of practice. Social robotics is a very active community, and as far as I know here, there are also people that are active in robotics and probably in this type of topics. Human-computer interaction has often involved some kind of social component, because in a sense it is a social interaction between people and machines, and more recently contributed to all of this wave of interest for social aspect of technology. Social signal processing has started to contribute as well. And let me show you also a similar curve, but a little bit smoother, and again with the same event of the birth rate. This is simply counting the number of papers, no longer workshops, but papers with the word social in the title. Again, a lot of different things, but you see what I did, it was to take IEEE Explorer and ACM and simply count year by year the number of papers with the word social. You see roughly the same type of pattern. And you see it stopped at 2012, last year, but the projections we have for 2013 shows further growth. Not as dramatic as it was between 2011 and 2012, but still it seems to be a community that grows. And social signal processing is just part of this bigger wave or this bigger interest, and it contributes with its peculiar particular type of contribution. So, what is this domain about? Now I'm going to show a picture that I think many people have already seen. I'm sure some people in the room have seen it several times. So it's a little bit of a game, so in this case, I'm sorry about, and don't cheat. But basically, I think it's still one of the best way I have to show how we in the computing community arrive to this type of domain. So the picture is this one, and typically represented, I say, well, can anybody tell me what is going on there? What are they doing?
An argument? Singing.
Yeah. Arguing, singing. You are a musician, right? I remember you studied music.
Me?
No? No,
No.
sorry, I understood. Other
They could be laughing together or something.
laughing together, yeah. Other. And if I ask you the type of relationship they have, friends, colleagues, couple, other,
Hate each other.
sorry?
Hate each other.
Like
You
each
know?
other. So they are a couple. Now, in the end, all of these interpretations are absolutely compatible with the picture. Because the picture are a couple of silhouettes, so we don't know who they are, we don't know what they say, we don't hear their voices, we can't see their faces, and all of these interpretations are absolutely compatible. There is no right or wrong answer from this point of view. But what is funny is that with such a poor information at disposition, in the end you find it evident what they do. And you manage to bridge a pretty wide gap between a couple of silhouettes and a very high level information like they are a couple, or they are arguing, or they are laughing, etc. So how can it be that we manage to do something like this? Well, because we tend to focus our attention very much on what people say, but there is always a lot of nonverbal communication going on. And here you have examples of what we call nonverbal behavioral cues. And we are very much sensitive to those cues, and we tend to interpret them all collectively in terms of social signals. So in terms of relational attitudes that people display to one another. So I'm sure that other people in the school will give better definition, more formal definition of what social signals are, of what nonverbal communication is. But again, this is the way basically the computing community came to this. So let me go just a little bit deeper on this. So basically when we talk about nonverbal communication, from the point of view of a computer scientist, you have mainly three big, let's say, elements. One is what we have just seen, and that's the nonverbal behavioral cues. And there are really a lot. So in a sense, just because we have a body and just because we are alive, we keep displaying nonverbal behavioral cues. And even if you try not to display a nonverbal behavioral cues, and that becomes a nonverbal behavioral cue. So in a sense, it's really something we cannot escape. And there are so many different nonverbal cues that some of them have been grouped by psychologists into 5 major classes, and they are called the codes. One is physical appearance, which might mean attractiveness, but also your clothes, everything you do in order to change the way you look like. Then we have face behavior, meaning not only facial expressions, but also, for example, the way we use gaze in order to communicate social information. Then vocal behavior, it might look a bit contradictory to say vocal, voice, and nonverbal, but basically it is everything in speech except words. So the way we talk, including, for example, the use of silence, if you want. Gestures and postures, and here by posture I mean, for example, the way you orient yourself with respect to others, the degree to which you imitate others with your postures. By gestures I don't mean that much things like this or this that have a very precise meaning, function, and so on, but really those spontaneous gestures, for example, that I keep doing to accompany my words, or this type of thing when you ask a student, what is this, and they, scratch their head, showing a bit of discomfort and so on, this more spontaneous type of gestures. And then space and environment. And this was pretty much neglected so far, especially in the computing community, but just think of how we have organized this room and how the organization changed according to what we are doing. And now the fact of being here gives you a precise role, which is different from the role you have when you are there. And by just switching position, we basically switch roles. So we really associate the position to expectation. So fundamentally, the organization of space can have a social meaning. And then there is the third important element. So nonverbal communication is a natural phenomenon, and like any other natural phenomenon, it fulfills function. And fundamentally, here is a list probably of the most important functions we fulfill with nonverbal communication, which are forming impressions and trying to look good or to look smart, expressing emotion. I think no need of explanation. When you smile, you look happy. Relational messages probably is the attitude you have with respect to others. Probably this is the most important thing from a social signal processing point of view. Very finally, deception management, so deceiving and symmetrically to detect deception. So Mother Nature seems to consider this very much important. And then power and persuasion, again, we descend from monkeys, and we have a lot of ways to show that we are the alpha individual in any group we are. Okay, so far I think I said in a very shallow and superficial way what any psychologist, social scientist, anthropologist, let's say human sciences researcher can say much better than me. But I'm a computer scientist. Why can I get somewhat attracted or interested in this type of thing? Well, very simple, because if you look at a lot of research, you can see that there are two interesting problems related to this type of scheme. One is what happens if I replace the person on the left with a machine. I put a computer there, but what I mean is a machine. So anything can display artificial, synthetic social signal. So think of social robots, for example, avatars, artificial agents, synthetic voices, and so on. And the question here, so the synthesis question is, can I generate artificial social signals, and can these social signals fulfill the same type of functions that natural social signals fulfill? Okay, and this is not something I'm going to talk about because it's not really my domain of expertise. What I'm going to focus on is the other problem associated to this scheme, is what happens if I replace the person on the right with a machine. And so, for example, is it possible to detect social signal? Is it possible to detect facial expression, prosody, the way of speaking, the way of moving, gesturing, and so on? And besides detecting social signal, can I understand them? Can I actually react to all the signals this person displays in the same way as a person would do? And this is the analysis problem in social signal processing, and it is the second important problem. And you see how basically we cannot address the synthesis and the analysis problem without a solid conceptual modeling. And so it is an interdisciplinary domain in the sense that without having someone telling to us where we have to look at when we want to understand a certain function of nonverbal communication, and of course we will not be capable of doing our work correctly. So it is not just synthesis, it is not just analysis, it always includes a modeling component. In the sense, someone that tells us exactly what the phenomena we are studying are, what are the nonverbal cues associated to that, and how all of these functions are being actually fulfilled in order to have automatic systems that either generate or analyze nonverbal behavior and social signal in human-human interaction. So this is a very brief and general introduction, but it gives you an idea of how, in a domain like computing science, that in principle has nothing really to do with this in general, we manage, or we arrive to, let's say, this need of elaborating something like social signal processing. So what I'm going to do now is to focus on two particular domains. So today I'm going to focus on personality computing, and we're going to see how this very general, this very abstract description is going to fit to a particular problem, which is the inference of the personality traits that people attribute to listeners they are unacquainted with. So let me just quickly change the presentation. And even more than the specific results or methods, what I really would like is that we get an idea of how we work in this domain, at least when it comes to the analysis part. So, first of all, we are going to see what personality is, because as I mentioned, it is an interdisciplinary domain. So our first effort as computer scientists is really, well, we study personality, let's try to understand as much as we can what personality is, at least to the extent that helps us to do our job well. Then we're going to see what it means exactly to do personality computing. We're going to see what is the relationship between speech processing and personality, and then again some results and some conclusions. So first of all, what do we mean exactly when we say personality? Well, here is a very nice definition. It says that personality is the latent construct accounting for individual characteristic patterns of thought, emotion, and behavior, together with the psychological mechanism, hidden or not, behind those patterns. And what is very nice in this definition is that it tells something very much important about personality, and it is something that plays a major role in social signal processing, and it is that personality is a latent construct. What does it mean? We are not even sure something like personality exists. It is not something we can touch, it's not something we can sense, it is not something we can feel, and still we can describe people in terms of their personality traits. So how can it be? Well, let's focus on the particular personality model that we adopted in this work, which is by far the most common, the most popular, is the dominant model of personality. It is often defined the latitude and longitude of personality models, which is the Big Five. Now, this is going to explain even better this particular characteristic of personality, because it says the Big Five personality factors appear to provide a set of highly replicable dimensions that parsimoniously and comprehensively describe most phenotypic individual differences. So, let's see what happens here. We have highly replicable dimensions. So again, when we talk about dimensions, we really talk about the geometric dimensions. So personality is described in this model as a point in space. And so the dimensions are absolutely abstract. It's not something you can see. It's not something you can touch. It is something that is abstract. And what is interesting is that they are highly replicable. That's why this model is so famous, because the dimensions, the Big Five, these 5 dimensions, these 5 axes, you can really find them everywhere. Now, it has been studied for 80 years. For 80 years, people have tried to find alternative dimensions. They never come out. They come out again and again, despite. Some have tried to reduce to 3, but it doesn't really work very well. So there seems to be a kind of empirical, but strongly consistent result. Parsimoniously and comprehensively, it means that these 5 are all you need. If you remove something from there, you lose information. If you add something to those 5 dimensions, it is redundant. So from this point of view is all you need, no more, no less. So they are parsimonious and comprehensive. And then you see that describe most phenotypic individual differences. So phenotypic, it means observable. And so you see very well these 2 layers we are going to play with. One is something that we cannot access, we cannot feel, we cannot sense. Personality, dimensions, these are constructs we do not even know whether they really exist or not. But we use that to explain something that we can actually observe and touch and sense and feel and detect with machines, which are observable individual differences. And in particular, in our case, nonverbal behavior. And you will see that a lot of work in social signal processing, it really consists always in bridging the gap between something that is abstract, cannot be observed directly, from something that is in contrast, concrete, machine detectable, physical, and so can be touched, sensed, and felt. Okay, a lot of work is this. In this particular case, we are going to see how we can infer from a particular aspect of behavior, personality traits that people attribute to an individual. So now that we've been mentioning these Big Five traits, let's see them briefly one by one. The first is extraversion. And you see each trait is accompanied by a number of adjectives, because the way these traits were identified was by applying factor analysis to the words people use in English to describe others. Guess how many there are in the English dictionary? Words to describe another person. Try a number. Yes, you should.
2,000.
More.
20,000.
18,000.
18, I said 20 was my second.
So it was discovered in the 30s by the guy that has basically elaborated the model. His name was Allport. They counted all of these words, 18,000, and then by just analyzing where they were used, you know, they realized that they were clustering into 5 major groups, 5 major factors, and they considered that this was an indication, let's say a kind of evidence, detectable evidence, of some silent psychological phenomena. And this is how the big 5 basically came out, and then they were confirmed again and again in any type of data. But so you see what are the adjectives that tend to be accompanied to each trait. So extraversion, you see, really etymological mean oriented towards outside, acting on the environment. Agreeableness, so etymological being ad gradum, so being agreeable to others, so being really nice with others, and feel appreciative, forgiving, generous, kind, sympathetic, trusting, and so on. Conscientiousness, so this has nothing to do with consciousness, it's another thing. It comes from the Latin word to be, it means to be reliable, it means to be organized, it means being conscious of your duties, conscious of all your responsibilities. That's the real meaning of this word. To see efficient, organized, planful, reliable, responsible, thorough, and so on. Neuroticism, again, many people think neurotic it means some crazy or bizarre. No, it is the tendency to experience the negative side of life. So being anxious, self-pity, intense, touchy, without being necessarily crazy. It's really just about being maybe a little bit sad or depressed or tendency to be pessimistic and so on. And then the last one is openness in the intellectual sense. So being artistic, curious, imaginative, insightful, and so on. And the funny thing about the Big 5 model for a computer scientist is that it represents personality in terms of 5 numbers. And the 5 numbers tell you how well these adjectives describe a person. So if you have a negative score, it means that you tend to be better described by the opposite of these adjectives. If you have a positive score, it means that these adjectives describe you well. And in any case, computer scientists, when they can transform something into a vector with a few numbers, they always get excited because you put that into a computer and you can do a number of very interesting things with that. Okay. So this is what personality is, at least I mean very little introduction to personality. Now let's see what does it mean to perform personality computing. So what does it mean to put personality into a computer or to process personality with computers? And we're going to see that it means mainly 2 things. So here we have a model which is very famous called the Brunswick lens, which is a general model of how people gather information in the environment. And this is adapted in particular to what happens during interactions between people. So we have one person on the left. This person is in a certain state that can be whatever you like, whatever you are studying, because the model is very general. In our particular case, the state is the personality. So this person, this woman here, has a personality. And we know that there is a process called externalization. So the person manifests her personality through basically everything observable she does, and we call this evidence of personality distal cues. That can really be whatever the person does. In the rest of this talk, it's going to be the way the person talks, but it is what the person does in everyday life, what person writes, the words used. I mean, you can imagine any type of behavioral evidence. Then, whenever there is an observer, and you see it here, so the distal cues, this evidence reaches an observer, and then there is a perception process going on. So as we are talking about speech, for example, well, sounds pass through ears, pass through the brain, and there is some process in there, so you do not really hear everything is in the sound. So there are some effects that tend to modify the physical signals that enter the ears. This is one case, but we can think, for example, of cultural effects. We can think of context effects. We can think of any type of effect that somewhat modifies the distal cues and transform them into proximal cues, which is what the person here actually perceives. And when there are proximal cues, there is a process which is called attribution, in the sense that this person is going to spontaneously attribute personality traits, and the result of this attribution process is a perceptual judgment. So you see, the person on the left has a personality, manifests personality through her behavior. The behavior is somewhat perceived by this guy, and this guy, on the basis of that behavior, attributes personality traits. Not necessarily the true personality traits of the individual. There is a good alignment in general. In general, we manage to make it appear what we really are, but it's not just something that we can do. It's also something that depends on others. We can be totally misunderstood. And in a few cases it's interesting, and I'm going to present it today. But in some contexts, actually, it's pretty easy to have total disalignment between what you are and the type of personality others attribute to you. So what does it mean then to perform personality computing? Well, two things. The first is that you put a computer here, and once you have a computer there, you can do two things. The first is what we call automatic personality recognition, APR, which means you can infer the true personality of an individual from the distal cues that individual displays. And it is called recognition because it addresses the problem of the true personality of the individual. And the second is to infer the personality attributed to this individual from proximal cues. And this is called automatic personality perception because it doesn't really address the problem of the true personality of the girl here, but it addresses the problem of what is the personality that others attribute to that person. Which is equally important because even if it is not the true personality, still the behavior of the others depends on what they perceive, not what is the real personality of the person. Okay? And if we look from a purely technological point of view, the methodologies are exactly the same. So we have some form of evidence, some measurable evidence, and then we infer statistically from their personality traits. What is changed is that in this case, you measure self-assessed personality. We are going to see how we measure personality, but in this case, it's this person that measures her own personality. In this case, you ask many people to measure the personality of the individual. Because when there is perception, you need to have several raters that actually provide you an indication, so that you can control the agreement and so on. And it makes it a bit more difficult because you need much more people in order to do the job. So it's a bit more complicated to collect the data. But basically, this is what personality computing can be. Now, in the rest of the presentation, we're going to consider in particular, for this case, automatic personality perception in the case of speech. But you see the connection with the general schema. We start from some form of evidence, and we try to infer something that we cannot really observe, which are personality traits, either the true personality of an individual or the personality traits that others attribute to that individual. Now, just to... Yes?
Just a short question. The true personality here, is that... is it taken for granted that that's actually, if I would describe myself, that is actually my true personality? I mean,
no, there is always a self-bias in the sense that you all tend in this, it's well known that when people self-assess, they tend to be positively biased, especially because in many cases personality is measured for job interviews or school things, so even more people bias because of course they know there is something at stake. But traditionally, it is made this distinction where the self-assessed personality is considered to be the true-ish, let's say, one. Let's say what has given a lot of support to that type of hypothesis is that at a certain point they started to measure self-assessed personality and then asking very close people, spouses, brothers, parents, etc., to assess the same person, and they've seen there is ample evidence that basically there is a very high correlation. So it tends to be kind of true. Okay, so you see that I love to collect this type of statistics. Once I started to work a bit on personality, I got curious, am I isolated? Especially because in that case I was a bit, very much at the beginning when I started a few years ago. It was 2009. There was really nothing in the literature or very little, so I got curious, am I isolated and crazy, or is there a bit of weight? And I did exactly the same game. So I went to ACM Digital Library and IEEE Explore, and I just counted the number of papers with the word personality in the title. And you see that again, until 2003, 2004, it was some kind of marginal, but since then, has kept growing. And now I have to say there is a little community working on topics related to personality, just to give you an idea of how they are distributed across the major topics. So take this with a little bit of flexibility, but what I did was really to go through all this publication and try to figure out some categories and assign all these papers to some categories. A lot of papers are about gaming. It's a kind of recent trend, but see how basically the personality of people and personality somewhat go together or interact. Human-robot interaction. So they've been very much active in the computing community, really in trying to give robots a personality, or to study how the personality of people interact with the robots. In the community of nonverbal behavior, which is the community I belong to, basically, there is recently good work on personality. Everything has to do with education and computing. There is personality. Social media, that's usually very well represented. Human-computer interaction, and then you see roughly 1/3 of the words actually is real personality psychology, in the sense that there is, I didn't know, but IEEE published a lot of work on management of programmers, of technical equipes, and so they publish a lot of work on how to somewhat put together teams where personality go well together, and so they can be more productive, and so on and so on. So you see, even in that bunch of work, in case a good third is real psychology, applied to particular technological work, but it is real psychology. So this is just to give you an idea that it's not an isolated effort, but again, it is going up, and actually there is more and more, there are more and more people in the computing community that get interested to that. Then what I did in particular, the type of experiment I did in particular, it was to see whether it was possible to infer personality traits people attribute to speakers from non-verbal aspects of speech. So first of all, why speech? Apart that maybe it's the only thing I know more or less how to do. But what is interesting is that if you look at the way people actually assign different types of judgments about emotion, about attitude, about personality, about any type of information you can perceive about people. So there was this very famous paper showing that when it comes to very global judgments about people, the channel we seem to use most intensely, and the channel that seems to be most reliable, at least as perceivers of others, is speech. So you see the judgments made from speech alone rather consistently have the highest correlation with one-person judgments. So this paper is nice because basically it says, when we want to perceive emotions, what we look at is the face of people, and that tells us a lot about. But when you want to get an idea about a person in general, and personality is a general description of a person, and the paper actually mentions several personality traits, well, when we want to do that, basically is speech that really gives us an idea of what the person is. So besides the fact that it's my kind of domain of expertise, it makes perfect sense, actually, to study personality based on speech. And what we did, it was simply to start collecting data about, and data collection is something very much important in social signal processing, because compared to other domains of computing where data, data means etymological, something that is given, something that is there, something that somewhat you cannot do anything about. Here in contrast, I think in our type of work, data collection is really part of the experiment. If you don't do it well, you don't manage to do any scientific or technological work correctly. So what we tried to do, it was simply this, to take a piece of reality, to take all the speech, all the people that speak in that piece of reality, and try to study from there how people attribute personality in a very precise context that we're going to see. So we are in Switzerland, we are in February 2005, and we simply collected samples of speech of all the people that have been speaking in the news during that moment. It's a very precise piece of reality, and in the end we managed to get 322 subjects, a total of 640 speech clips, and each one of them was 10 seconds. In the sense that we really cut pieces of 10 seconds of all the people that have been speaking. And for every person, you see there are 322 subjects and 640 clips because some people have been speaking more than once. Now we're just going to play a couple of samples just to give you an idea of what it sounds like.
C'est la situation qu'on n'avait aucune chance d'élire un candidat au premier tour, sauf en disposant d'une espèce de star de la politique valaisanne. Et sur la...
So can anybody hear comfortably? Is that okay? Another sample with a female voice.
Il est soupçonné de gestion déloyale dans la base de l'institution. La case fidélité revient à un autre indépendant, Michel Garot, pour la troisième fois.
So you hear the type of thing, really a piece of speech extracted from the radio, 10 seconds, no attention to start at the beginning or at the end of the word, really 10 random seconds extracted from each and every person that has been speaking in the news during that moment. Then how can we manage to measure the personality of the speakers based on such a little piece of audio? Well, basically you ask raters to answer those questions. This is a questionnaire called the BF510, Big Five Inventory 10. So it is an instrument to measure personality. Each one of these questions is related to a Likert scale, from strongly disagree to strongly agree. And by just manipulating those scores, basically you manage to get the 5 numbers that describe the perceived personality of that individual. And you see here how the different questions are related to the different traits, so extraversion, agreeableness, and so on. Okay, and so what it is was simply to take 11 poor people, ask them to watch all of this, to listen, to all of 640 clips, and for each clip to fill this questionnaire again and again and again. It was pretty hard work for these poor guys, especially because they were British, so they didn't understand at all what the people were saying. So we did this exactly because we wanted them to be influenced by nonverbal behavior, by prosody, by voice quality, by whatever it is, and not by words. Okay, so that was a bit the game. So here are the characteristics of the database that came out. So 640 clips, roughly 2 hours of material. Gender balance, not that good, but apparently the Swiss radio tends to privilege men very much. In contrast, there is a balance in terms of 2 categories of speakers that were there. So the raters didn't know it. But fundamentally, you have journalists, roughly 50%, and another 50% of guests, meaning people that were, for some reason or the other, speaking on the radio. So you have, for example, people that have seen an accident and they explain what the accident was, people that went to the latest big show and give their impression about the show. I mean, this type of, common events that radio describes, and you have common people talking to that. And you're going to see that this is kind of interesting. Just to give you an idea of the speaker distribution, in the sense how many times every speaker talks, so roughly 60% of the people appear only once, another 20% appear twice, and only a few others actually appear more than 3 times. The most represented speaker is represented 16 times. But in any case, in all the experiments I'm going to show, they are speaker independent for those who do statistical approaches, meaning we never train our approaches on the same speakers where we test. So somewhat, we are sure that we are not, whatever are the results, we are sure that we do not have simply memory of speech, but really we predict personality, attributed personality traits. Now I'm going to play a few examples, and just to give you an idea of how people react in terms of attribution of personality traits to different ways of speaking. So we start with a person that was perceived to be very low in conscientiousness, meaning that the person was perceived to be not particularly smart. So I don't know if it was clear, etc., but for those who do not speak French, he's a non-native speaker that actually has a certain difficulty in speaking French, and funnily enough, the British people got it in the sense of someone that is not particularly smart. Maybe he's really not smart, but we don't know. He's actually a football, it was at that time the coach of a very famous soccer team, so I need to just have such a can be smart also. Now let's hear someone that in contrast was rated very high in conscientiousness. We are on the other side of the spectrum.
Un engagement militaire en Irak, l'enlisement du conflit rapproche aujourd'hui ses camps et les États-Unis ont besoin d'une Europe unie. Une Europe unie et forte basée sur des valeurs communes aux deux continents.
So you hear, she's a woman, and you hear it's a totally different way of speaking. You can see that there is a difference. Now let's hear someone that is very low in extraversion.
Peut-être appliqué, revu et corrigé par marketing. Ils ont distribué des brochures.
He's a politician, so kind of very quiet person. Look like now, let's see someone that is very high in extraversion.
On modèle la social-démocratie, version scandinave, les Portugais ont réussi avec la majorité absolue. Socrates devra maintenant tenir sa promesse, tout faire pour sortir le temps.
So you hear, totally different way of speaking. So you hear how people basically have, this is very qualitative, now we're going to measure it, but how people seem to react when they attribute personality traits in different ways depending on the way people speak. So the very first indication we had about this, it was really relying on the presence of these two categories. So the raters do not know about the categories. They just attribute personality traits to people they have never heard before. And what happens is this, and we know that roughly 50% are journalists, another 50% are, let's say, guests. So what we did was to take all of the personality assessments and to make PCA out of that. And for those who are not familiar, principal component analysis, it is just a way to take 5-dimensional points and project them onto a 2-dimensional plan in such a way that points that are closed in the original space are closed in the new space as well. So each point there is an attributed personality, fundamentally. So you have 640 points, in the sense that we have 640 clips, and so 640 assessments. And every assessment is just the average of the 11 assessments that the different raters do about the same voice. Okay? Now, if you look like this, you see that it's very much uniform, and it is good because the big 5 traits are not correlated, so it's good that they are so uniform. But if you give a different colors to those who are guests and those who are journalists, you see that even if there is a lot of overlapping, actually there tends to be a different distribution, which basically show how actually people tend to assign different personality traits to the different categories, which means that really, there is some sense in the data. And we measure this a little bit more concrete, a little bit more quantitatively by basically doing what? Using the personality assessment features and trying to predict automatically based on them whether a person was belonging to one or the other category. And you see that we managed to do it at the 75%. We perform the same task using prosody, so using prosodic measurement. In a moment we're going to see what I mean exactly by that. It works, of course, much better because prosody is all that people have at disposition, and because the two categories from that point of view are much more diverse. And then you see that we managed to combine the two and still get a little bit of significant improvement, statistically significant improvement with respect to this. But basically this confirms that somewhat personality traits were not attributed totally by chance, but the fact that people that speak so differently belong to different categories, and they speak so differently that you can perceive that automatically with prosody. And then you manage to repeat it to a certain extent with personality, shows that the traits were attributed with a certain meaning inherent. Okay. So this was a first confirmation that actually the data could work correctly. And at this point it was time to really try the experiment of trying to see whether we can predict the personality traits attributed to a speaker simply based on what we can measure on speech. So I think here there are people much more expert than me, Jens and Jürgen, on how to extract physical measurement from speech. But what we did was something very much simple. I'm not going to give that many details. Basically, we tried to get the way people talk by concentrating on areas that correspond to vowels, taking the nucleus of the vowels, because this is the part of the speech where properties are more stable, and fundamentally measurement, the pitch, which basically accounts for the way your voice sounds, formants, the length of voiced and unvoiced segment to get an idea of how fast or slow people speak, because I mean, the faster you speak, the shorter on average will be this type, but it's a very indirect and noisy way of measuring the speed of speaking. But just to give an idea that we measure really something very much low level, and all we do is we measure this many times during 10 seconds, because you have many vowels, and then we just get the averages or statistics over the entire clip of 10 seconds. So it is a very low level, very, very shallow, not particularly difficult from a technical point of view measurement. And then the task we do, it was simply to say, we can, for every trait, say whether a person is above or below median, and we can simply try to predict whether someone was perceived to be above or below. So it is a very simple task, and we did it using probably one of the simplest things you can imagine, which is called logistic regression, but it has a very nice property we are going to see after a while. So the way it works is this. Basically, you train this model, and what you get out of the training is a vector, theta, that has this very particular property. If you take an hyperplane, in this case, imagine that you have three kind of measurements. You can have much more, but this is just an example. You take a plane, it is perpendicular to theta, and it crosses theta at distance t0 with respect to the origin. Then what happens? When you have a piece of speech, you extract all this measurement, and you will get, for example, this point x. These are simply the measurement you extract from speech. You project that along theta, you get a projection here. This projection is along theta, this is simply the scalar product of the two vectors, and this, if it is lower than theta 0, so then this distance here, it means that you are on the left of the plan. Otherwise, you are on the right side of the plan. And what happens, this algorithm simply does this very simple thing. It says if you are on one side of the plan, then you are, let's say, low in extraversion or in whatever trait. If you are on the right side, you are high. Now, what is funny about this is that this vector theta gives us an idea of the orientation of this plan and gives us some indication of what are the measurements we are using that actually influence most the decision of the algorithm. And so indirectly, that actually influence most the perception of the letters. So let's go to see what are the results we get. And you see that here we have, for every trait, we have three different bars that correspond to focusing the experiment on the more and more consensual pieces of speech. Meaning, n is the number of raters that agree on the person being above or below median. So you always have at least 6 people agreeing, because we have 11 assessors, so at least you have 6 all the times. But then you can have at least 7 or at least 8. And of course, going up with the number of letters that agree, going up towards least ambiguous cases, the performance goes up. But when you look, it's not even that significant anyway. And then what you see is that basically we managed to get, if you concentrate on the first bar, the one that we use when we take all the data as they are, including the ambiguous, you see that we are a little bit above 70% for extraversion and conscientiousness, while for the others, no, we are around 60 here, around 60 here, and some 65 in the case of neuroticism. Now, they are all above chance to a statistically significant extent, so none of them is actually not working, but only extraversion and conscientiousness actually go really above to good performance. Now, is that normal? Is that good? Is that bad? Well, first of all, for sure it is compatible with what the psychologists tell us about the perception of personality. You see, there are two dimensions that underlie most judgment of traits, people, groups, and culture. The first makes reference to attributes such as competence, agency, and individualism, and the second to warn communality and collectivism. So, competence and warn basically are conscientiousness and extraversion, so we see that whether we are doing well or bad, because we do not know, we were the very first to do it, so somewhat we didn't really know whether it was good or bad. At least we are in any case compatible with what psychology says. That in the end, extraversion and conscientiousness are in any case the traits that we immediately perceive in others. But then there was something even more fun to do. You remember that I said, well, use the logistic regression. There is a reason, because this theta vector can give us indication about what are the features that actually influence the decision of the algorithm, and then in a sense tell us what are the features that actually influence the perception of the raters. And what you see here are the components of that theta vector. And so here we can see, so the bigger the component, positive or negative, the more it means that that feature influences the decision. And you see here that the most important component seems to be the entropy of the pitch, which is a measure of variability. Something that is bigger when more values of pitch are represented, where there is more variability in the pitch signal of the speech. Same thing for the formant here, and same thing for the energy, which basically means that people that tend to have higher variability in the way of speaking, whether it is pitch, whether it is formant, the first formant that has to do with the type of phonemes that are pronounced, or the type of sound that appear, that the person used, or energy, is loudness basically, tend to be perceived as more conscientious. Which is, something we all know. People that speak monotonously, we do not really like them. Now, is this compatible, again, with what the psychologists say? Well, let's have a look. Rate and pitch variation were the most influential for competence and benevolence, respectively. For competence, one interaction effect, rate by pitch variation, was significant. So you see that again, in the strongest effect we have observed, which is the variability of the pitch, we are actually consistent with what the psychological literature says. And by the way, we are using one particular paper here, but you can see there are actually many papers in psychology that somewhat say the same thing. So it's not a kind of punctual result. Same thing for extraversion. You see once again the variability of pitch plays a major role. And then there is a little bit more of effect when it comes to the distribution of the length of voice and unvoiced segments, which it is a very indirect and noisy measure of how quick a person speaks. And the way they are placed here, they seem to say that there is a kind of U-shaped effect, meaning if you are too slow, you are not considered to be extrovert. If you are too fast, you are not considered to be extrovert. But if you stay in a certain range, you are considered to be extrovert. And once again, if you go to exactly the same patterns, basically I say rate and pitch variation were the most influential for competence, so conscientiousness and extraversion. And for extraversion, two interaction effects were significant. Pitch variation by loudness and pitch variation by rate. And again, you see it is exactly what we are seeing. or at least in part, because we didn't see the pitch by loudness, but also we have to say that in this type of data you don't really have major variation in loudness because it is people speaking on the radio. So somewhat we see that whether we were good or bad at this task, we do not really know for the moment. At least we were fully compatible with the indications that come from psychology. But in any case, it means that we are actually at least consistent in everything we are measuring and predicting. And at this point, you know, the real question was, okay, in the end what we did is something very simple because it is a binary task, so from a technological point of view it's not really exciting. Are we doing something good or not? Is it because of us or is it because of the problem? So we were lucky enough to be involved in the organization of an international benchmarking campaign that was held in 2012 at Interspeech. It was called the Speaker Trait Challenge. And there were 21 research groups that basically tried to do exactly the same thing we did, using exactly the same data. So we gave our data in order to organize this. And this, of course, was supposed to tell us whether we were limited or whether there were actual problems. It was actually a difficult task. Now, only 9 were selected, and selected means that they were good enough to be statistically significant above the baseline provided by the challenge organizers. And also, I mean, there is a review process, so they were writing well enough to be accepted at the conference. But this gives a first measure that in the end, I mean, it is not that easy. If you have less than 50% of the people that manage somewhat to pass those thresholds. And here you get an idea of what were the performances along the different traits for this particular task. So just to give you an idea of the range, the smallest dot here is roughly 65% performance, and the bigger dot is a little bit less than 80%, but let's say 65 and 80. And here you see, these are all the participants, these are the traits, and you see that roughly what you observe is the same pattern we had. Extraversion and consensualness going better, the other traits being recognized so and so, with neuroticism exactly as in our case being in a kind of intermediate situation. And here is where we were, you see, not particularly strong, but you know, pretty much close. I mean, they said that the difference seems to be very big, but it's just because they are enhanced in order to be seen. But one first indication we get is that in the end we were not that bad. So it's not that we were bad at doing our job, it's really that the task appears to be very much difficult. And really these different groups have tried everything possible. So there is nothing that seems to work for all the traits, there is nothing that seems to work better than anything else. It really means that the task is particularly difficult. If you have any type of approach that has been tried. They have tried something like 6,000, it's not an exaggeration, it's the real number, 6,000 different features. Each one of them uses different machine learning approaches. So it really appears to be a definitely challenging task. And then there was an interesting indication that came out for that. So here we see in any case that the task is actually challenging. It's not such an easy task, even if technically it can be performed with relatively simple means. What was really coming out is that what was missing in our original feature set, in our original set of measurement, it was voice quality. That was really appeared to be something extremely important we have missed. So we have added. So voice quality is basically measurement related to the spectral properties of speech. I'm sure that Jürgen or Jens can explain it much better than me. But fundamentally tell how energy is distributed across different frequencies. So for example, the centroid is more or less something like an average using the amount of energy as weight. Skewness, how much it is distributed above and below the centroid. Slope, how much it goes down, energy going up with frequency, and so on. But basically it was a part, let's say, of the speech description that we were missing. And by adding that, you see, we managed to get some definitely good improvement. And at this point, we are really in a statistical fluctuation with respect to all of the other group, with in particular on neuroticism, we managed to go much better. Now at this point you can say, okay, we are satisfied, we are happy, we got this type of result, we improve our approach, but the real point at the point was, if everybody goes so, I mean, not that fantastically, probably it is because we are not really doing the right thing. And so, one thing we typically do in social signal processing, when we are stuck in such a point, we go back to psychology, or we go back to the human science literature, and we try to see whether we are really doing the right thing. And it turns out in the end, something like this. So a comparing argument can be made for emphasizing comparison among individuals, which we do in everyday life, and which is useful for practical purposes. What does it mean? Our original idea of trying to predict the actual traits that are attributed to a person, it was probably not the smartest thing to do. What we do in life is simply to compare people. And so probably a smartest idea, it was not to work on trying to predict whether a person is 2 or 3 or 1 in extraversion, but it was to say, give me 2 pieces of speech. Who is the most extrovert? Who is the most conscientious? And so on. And by doing that, actually, you see that the performance definitely went up. So we are now well close to 80%. This is also an old result, and we are further improving. We obtain this by using ordinal regression, which is a particular technical approach that helps you exactly to predict order whenever you have a labeling of your data that reflects some type of ordering. And you see how, in particular, this tends to be robust, depending on the number of ordinal classes we use. What does it mean, an ordinal class? So we take from the lowest in extraversion to the high in extraversion, we cut it into a number of classes, and of course, the more classes we use, the more the problem becomes difficult, but the more fine-grained is our distinction. So with 2 classes is basically what we did before, being on one side or on the other, so just putting the people in the 2 classes, and by increasing the number of classes, of course, you get a finer and finer distinction. And this is really something we got at the very last. We are still working on that. We are still trying to transform the particular approach we are using here into something that helps us to understand, as we did in the case of logistic regression, to understand what are the features that, again, to see whether it is confirmed that we get the same feature influences the decision or not. Now, just very briefly, one interesting thing is that personality is really attracting more and more attention in the computing community, in part also for this effort we did with the benchmarking campaign, so the data is publicly available, everybody can use it. It's become a kind of more attractive task from that point of view. One thing that, I've shown an example here, but you can find it in many other different, if you look at the literature, there are many other works. So in any case, personality leaves physical, machine-detectable traces accessible to machine and computer, and these are consistent enough to how can I say, elicit the attribution always of the same trace, or let's say always, with sufficient agreement to be detected automatically of traits. And the reason why this is very much interesting for computing is not just because we like to do personality, but the old dream of having computers that interact with machines in the same way, interact with people in the same way as we do, requires you basically to understand people in the way we do it. Personality seems to be our own way of looking at other people. So if computers somehow manage to automatically perceive personality like we do, and that somehow will help computers actually to be much better at interaction with people. Okay, thank you very much, and these are a number of people. Thank you.
So, thank you very much, Alessandro. Especially thank you for intuitively understanding that we need 10 minutes at least for discussion after each talk, which is precisely what you left us. That's very good. So now, questions, comments. If no one else, I will start by one question. And this is a fundamental question. You know that people are not at all agreed in social science that personality is important. Actually, it's a very controversial idea that there exists personality at all.
Yes.
So there's a very large school of people, maybe today most forcefully represented by so-called conversation analysis, who think that personality is a myth, more or less, and that when we go around in life and we act, it's always a product of the situation and the context. why are you pursuing this, or what are you doing?
Well, no, you're right, it's controversial. At the same time, I mean, as there is a literature that says maybe it's a miss and everything is on the situation, you have a literature that tells exactly the opposite.
Yeah.
Now, typically, this is important, for people like us that do the technological side of social signal processing, in the end what is important is what we manage to do with machines. And for us, what is extraordinarily appealing is to have one model that somewhat managed to capture what, in any case, is a mechanical phenomenon that we observe, because these experiments, like all the other experiments you can see in machine and personality, show that we react mechanically to a certain extent to what people do, and part of this reaction consists in attributing characteristics to people. And observing such a mechanical phenomenon to the point that we manage to predict it, it's something that can make the life of machines when they deal with people much easier. So from that point of view, for us the question whether personality exists or it is a matter of the situation is relatively unimportant as long as we manage to infer reliably what one person thinks about another person or feels about another person based on something we can measure. Then you can have a lot of approaches that are totally situation-based. I mean, you can do it in a totally different way and forget about personality and base everything on situation. We're going to see, for example, when I'm going to present conflict, that is, in a sense, totally situation-based. You measure something, you don't care about people, you just infer a conflict level from something that is very specific of the situation, and the conflict level changes for the same people according to the different part of their interaction. Which shows once again how, for us, it's relatively unimportant whether something exists or not. What is important is how measurable, how statistically reliable is, and how solid is this relationship, this possibility of statistically mapping measurable stuff into non-measurable or non-accessible stuff. So I don't know if I answer your question.
I think you're saying that we could view what you're doing as finding situation-based attributed personality properties.
Yeah. Yeah.
And we don't really have to believe in personality to find the same correlations that you're finding. I mean, that could be a compromise.
No, still
not a compromise, but a way of solving the puzzle.
Really, if you take the same person, you take another sample of speech maybe in a different moment, and you will get different ratings. So you see.
Right. Okay, so Eric had his hand up,
Okay, I start with a question. Go back a few slides, please. I was this, for example. What is R here in that?
R, that's the number of ordinal classes. So this is an ordinal regression approach, which is simply a statistical approach to say, okay, I have labelings, and these apply to personality labels that reflect an order. So in personality, in the end, every person is assigned a label between -4 and 4 in our case. These are just arbitrary numbers. And this number is not that much of an intensity, it's not that much of a value that should be taken as an indication of position, but it's something that say, if you are 2 and the other is 0, what it really means is not 2 and 0, it means that one is higher along a trait than the other. So the number of classes simply means I take my range, my observed range, and I split it into a number of different classes.
And the standard deviation bars there, are those the standard deviation among the...
This is let's say, the difference you have to add in order to have a difference which is statistically significant at 5% level.
Yeah,
so
among the people assigning a certain property to that.
Sorry, how?
Among the people answering the questionnaire.
No. This is much more statistic based. The point is we measure performance. We have a certain number of samples, a certain test set, etc. So if I apply another algorithm, if I want to be sure that the difference is statistically significant.
Okay, yeah.
So it depends on actually better algorithm and not just that chance.
Okay, so I posed the question. My question was really, if I would do this,
Yes.
how well would you guess that I mean, how big is the deviation between people actually assessing properties from sound, as your experiment was?
So you mean the agreement between the raters?
Agree? Yeah, exactly.
The agreement between the raters is, we have measured, is significant, is low. We are around 0.2 across the different rates. That might look very little, but it is what you observe in the literature for similar problems. So if you go through the literature, you see that many times this problem was posed. So what happens in a scenario like this, where people have at disposition a little behavioral sample, 10 seconds of speech, and they're totally unacquainted, and roughly that's exactly what it is typically measures. One important thing is this one. When we talk about perception, there is no well or bad. People say what they think about the person.
Of course, but
So there
it
is
could
no
be
right
more or
or
less, I mean, close to the mean. But
Yes.
what I was fishing for actually was that I mean, in robotics and what I have been dealing with quite a lot of behavior recognition, which you could see a little bit similar to this, is to go more and more towards a view where the agent, the person in this case, would use his own experience, his own motor system in order to do the recognition, which might sort of throw away the feet for actually viewing this as a pure perception problem, but rather as an integrated view and of course situation dependent and so on.
Yeah.
And that would, if there were actually, you could find groups among people structurally assigning I mean, these properties differently, then that would be supported.
Yeah, I have to say, I mean, we took 11 assessors, all British, all university students. It was very much...
it wasn't very homogeneous.
Exactly. We tried as much as possible to have a kind of uniformity across the different things. In a sense, what we measure here is property of the assessors. So in principle, what would be really nice to do is to have as many assessors as possible, but really hundreds, and then to get a distribution of the assessment given based on the physical properties, and to predict the distribution more than a specific thing. Of course, that is a totally different type of experiment. There are technical and feasibility complications, but in principle, that's what it is about. It would be nice to have. And for example, we are doing now other experiments on totally different data. So we are using the picture that people post on Flickr, just to see how this communicates personality. We're seeing this very funny thing that basically it has nothing to do with your personality, but it stimulates very clear personality attributions on others. And we are now measuring we did it with Italian assessors, and we are now doing it with Chinese assessors, to see at least if culture makes a difference from what point of view. But then we have exactly the same problem. We should measure a distribution and not really. But for doing that, it's another work. I mean, since the entire experience should be taught differently. What remains amazing to me in any case is even done in such a relatively simple way, the signal very strong is that we react very much mechanically in any case to that.
We really support to start with breakdown, but I can see at least two people, but you're not allowed to ask the questions as long as me and Eric did. So, so we have here Christina.
I will keep the answer short.
Yeah.
Actually, I have two questions. One is about these classes here, because it seems to me that the extrovert and competence seems to be best or highest, say, recognized, and the others not so much. Did you try sort of just having two-class distinction between?
No. These are not classes.
Okay.
These are not classes. These really are factors that come from this type of analysis. It's not an arbitrary decision that we decide. This really, if we accept the Big Five model, really
Okay.
we have to stick with it because conceptually that describes in principle how we really perceive them. We don't manage to explain. But just to give you an interesting thing, my colleagues in neurosciences show that when it comes to extraversion and conscientiousness, there is a piece of the brain that reacts specifically to that. And it is a very ancient part of the brain, and the reason is that basically a decision about extraversion and conscientiousness basically tells you whether you can engage with the person or it's better you run away quickly. So it seems to be a very strong instinct that comes from the time where, you know, in the jungle you meet someone, you quickly have to decide. So it seems to have even a cerebral basis related to these two.
Because I thought, well, maybe these sort of traits could be kind of divided in two, but we can take this maybe later. Because I also wanted to say one comment was about when you said related to Ekman, etc., is that speech is the most important part of personality. And what I thought is that speech also conveys the conceptual part. So how much is this personality related to our understanding of what person says and what they talk about and the topic that interests us, etc. Nothing to do with whether it's conveyed by speech, but by
let's say
conceptual.
What they measure it was this consistent, very high correlation, higher than any other channel with this kind of general judgment about people that for sure probably, in their cases as well, they I don't remember what they use. I think they were messing up the signal in order not people to understand what say, so it was purely non-verbal. But it seems to be the channel we use to sort of have this more general judgment. Empirically, again, they didn't give any explanation, it was an observation experimental.
Okay.
Yeah, I just take one of my questions then. I think it's related to Christina's latest point that now the data you have here is from people listening to someone who is speaking to the public, like you are doing now, in a sense of. While the model you showed in the beginning, it looked more like a model of a dyadic interaction between two people. So wouldn't it, I think it could be quite different, it would get a quite different result if you had people interacting face to face with each other, not only because you get all the non-verbal signals, maybe which you would like to control away here, but also that you get the reciprocity that is not in this.
Yes.
And maybe that would be...
Well, the model is bidirectional actually, so the model somewhat is very general, and also there it is adapted to this type of interaction, but it's very general about how we perceive relevant information in the environment about everything. So yes, clearly, if you put people in direct interaction, it's going to probably be very, very different. But again, there are digital cues in any case, much more probably. And in any case, there it shows this type of directionality, but you can switch and it is exactly the same thing. Here, to simplify, you get this unidirectional thing, but it's the same thing in two different ways.
Because if a lot of our understanding of others requires that we actually react to their cues and they react to ours, to get the turn taking, because is in the...
Clearly, this is a particular scenario, and
but it depends on what you want to model, of course.
No, the level of perception, there's no right or wrong, so no true or false. I mean, so changing the scenario can totally manipulate.
Thank you very much.
Thank you.